Okay, so it's on number 8, it's pretty obvious that this one is not 1 fraction equals 1 fraction. So it is not that we can cross multiply again. So what I'm going to do now is what I should do with all of these problems, and that is factor the denominators. Okay, so if I factor this first denominator, I can pull out a 2. If I factor this x squared minus 1, I get x plus 1, x minus 1, and then x minus 1 is factored. So knowing that both methods require a least common denominator, what is my least common denominator here?
X minus 1.
We've got an x minus 1 as part of it. X plus 1 is part of it. And we need a 2. Okay, because we have to have each of my denominators represented. Remember, to be a least common denominator, this entire denominator of 2 times x plus 1 needs representation. So I have a 2 and an x plus 1. And this entire denominator of x plus 1 times x minus 1 needs to be represented. And I have that here. And then the entire denominator of x minus 1 needs to be represented. So you can see that each part of my original problem's denominator is represented in that least common denominator. You see that? Okay. What it seems like to me, is it true that most of you like that second method? Most of you do. There's a couple no shakes, but most of you do. Okay, we'll do method 2 then. And really all that method 2, and it doesn't, you guys don't even have to notate that you're doing method 2. I'm just going to put it on here so you can see it. What that means I need to do is I need to take each of my parts of my equation and multiply by the part of the denominator that's missing. So I'm just multiplying, oops, got ahead of myself, top and bottom of each fraction by what's missing from the fraction. And what's missing from each piece. So from this first fraction, I was missing the x minus 1 component. From the second fraction, I was missing the 2 component. And from the third fraction, I was missing a 2 and an x plus 1 component. Okay, so we ready? Now what I'm going to do is I am going to multiply each of these fractions. So I'm going to get x minus 1 over this whole lovely denominator plus 10 over the whole lovely denominator equals 2x plus 2 over that whole denominator. Yep, go ahead.
How'd you get 2x plus 2?
Because I took this 2 times x, or 2, and multiplied it into the x plus 1.
Okay, thank you.
Yep. Okay, now the whole point of this method is that all my denominators are the same, so I can ignore the denominators, because if they're all the same, then it works out that all I need to focus on are my numerators. And now I can combine like terms. So we get x plus 9 equals 2x plus 2. I'm going to move my x and move my 2. And so we get x equals 7. And we just want to check do a quick check to make sure that that x equals 7 does not cause my denominator to be 0. But it does not.